see, and we're live. All right. Welcome everyone, and well, hello everyone, and welcome to today's webinar. We're very, very excited to have you all here. This, as you might already know, is a webinar series where we're introducing and explaining some of the interesting open source projects that stem from VMware. And the topic of today is Project Dispatch and serverless functions. If you have any questions throughout the webinar, please add them to the Q&A you can find at the bottom of your screen, and we will answer them throughout the presentation. We also have a poll going right now, so we would really appreciate it if you would take a few seconds and answer them as we're getting started here. Our speakers today are Dispatch project lead Bernd Jung and project founder Mark Peek from VMware. Mark has been working within the open source space even before the term open source existed. So he's a veteran within the open source space for sure. So I'm really excited to hear what Bernd and Mark is going to talk about today. And as you all know, this is an interactive webinar, so please ask as many questions as you can. With that, I'm handing it over to Mark, who will start the presentation.
Hi, everyone. Welcome to the webinar. Just a second. So I wanted to first start off with talking about, why functions, and then Bernd, we'll talk a little bit about just generic functions, and then Bernd will talk more about Project Dispatch and where that's headed. So why functions? We've started off with bare metal, and then VMware helped revolutionize with the ability to have virtual machines. And then over the past couple of years, we've seen the migration to containers, and now this new construct, this new cloud-native architectural pattern of functions has arisen. And the reason, as we're looking through this progression, we're seeing that over time there's a decreasing concern and control over the infrastructure implementation, but at the same time we're focusing more on what is the business logic associated with how you deliver your applications. And so as a developer, I just want to be able to write my code, hit submit, and have it up and running, and not have to really deal with a lot of the infrastructure concerns around how do the machines actually get provisioned, et cetera. I just want my code to run. And so we see functions as, on this progression, as a way for these developers to really focus on their business logic. So what is a function? When we're looking at this, it's a piece of code that's running, a function, along with its dependencies. It's triggered by something that happens from an external side of things, so it's event-driven. Some event, HTTP request, a timer, something gets queued into it that causes a trigger to occur, and that function then to be run. The function is stateless, and because of that, it's now more easily auto-scaled, so that as the events are coming in, you can now scale up the number of instances of those functions that are running in order to address the needs of the business and handle all of those requests coming in. So the back-end services could be that it talks to databases, it could enqueue something onto a message bus, could give an immediate result. There's a lot of different ways for it to communicate back, but being able to handle burst of load coming from something like IoT devices, mobile devices, or just your normal website makes it very handy to be able to use. When we're looking at how long does it last? Typically we saw with virtual machines that, you have a virtual machine that would last for, days to years, depending on how much you enjoyed naming it. The cattle versus pets analogy. And then the other side of this is that with functions, we're seeing lower cost. Now, lower cost is in public cloud, potentially that you're not having to pay for the infrastructure when you're not using it. But there's also lower cost with respect to developer time. As you're reducing the need for your developers to think about infrastructure, they're now able to deliver more business value at a lower cost and focusing just on that line of business. So what are some of the use cases? I've listed quite a few here, such as microservices, where you might have stateless applications or bursting workloads. IoT, which I had mentioned before, doing mobile app backends or even edge computing. Another interesting one is just stream processing. You might have job queues that you need to handle. You may have the ETL, the extract, translate, and load types of workloads. Be able to have those go into a serverless, a functions as a service in order to auto scale up the number of requests coming in. DevOps, we're seeing it in terms of notifications and CI/CD pipelines. And then just general IT operations. How can you do provisioning and other automation more easily using functions? So let's talk about just a couple of serverless use cases. These are more focused on public cloud, but I think that they're very interesting. Nordstrom has a open source site that's called Hello Retail, where they've designed a retail site that is entirely written in functions and using back-end services of the public cloud. And it's very interesting to be able to decompose something that a lot of businesses have, which is a retail site, and decompose it down into how would you actually structure that into different functions, and then tie that in to the databases and other attributes that are required to store state or provide data to that retail site. Another one was Coca-Cola has talked about their Coke machines, where when you swipe your credit card to buy a Coke, that then will trigger a function to be run that will do the transaction processing. Now, the nice thing about this for Coke is that they only have to pay for the compute in the public cloud when someone is actually doing a transaction. And so it's a very, one-to-one, they understand what the costs are. But in the talk that they gave, it was interesting where at a certain point, it made more sense for them to not use public cloud functions, but to switch to their own infrastructure. And so you really do have to look at where is the break-even cost for, especially in public cloud, around when do you actually run your own versus use that public cloud function service. Some of the things that have been going on in the community is to understand what is serverless. And the Cloud Native Compute Foundation, which is the foundation that has Kubernetes, Prometheus, and other open source projects associated with it. We went to them and said, we'd like to talk more about what is serverless and have an opinion about it. So a bunch of us got together and we wrote a white paper to discuss what is serverless, what are the aspects of it, and then what should we be doing about it? We shipped the white paper earlier this year as a 1.0. We also pulled together a landscape in order to be able to say, what are all the projects that are occurring in serverless at this time around both public cloud and private cloud on-prem use cases. One of the projects which Bernd will be talking about is our open source dispatch project, as you see here listed in the landscape. And at the end of writing the white paper, we decided that we needed to go off and look at other further harmonizations. And so the next area that we started talking about was around cloud events. And so we created this CNCF sandbox project to be able to understand what should we do around how do you send events and identify events going possibly between clouds. And so at KubeCon in Copenhagen in May, we actually did a fun demo. This was Austin Collins from serverless.com gave a talk about the cloud events and also about how we did this interoperability demo. So we had two publishers. We had AWS publishing and also Azure going into either Event Gateway or Azure Event Grid, where it would then generate a cloud event. Those cloud events were sent to a variety of different subscribers that would then do something with that cloud event coming in. The way that we structured this was to create the cloud event as a link to an image, and then we would do each of the subscribers would do something with that image and then post out to Twitter. It was great to be able to see, just the breadth of the teams that were working on this spec, the breadth of which the projects were able to align behind the 0.1 specification. And then, the fact that we were able to pull together this really fun demo of how we see this working in the future. And so with that, I want to hand this over to Bernd to be able to talk about our open source project, Dispatch.
I see there's stuff in the chat. Jonas, are there some questions that we should sort of take now, or should I just keep going into Dispatch? All right, cool.
No questions right now. We just had an issue with someone not being able to see the slides, but that's corrected now.
Awesome, good. Okay, yeah, so my name's Bernd. I've been sort of leading the Dispatch project for the past year or so, since before it was Dispatch. But Dispatch is our take on functions. And so us being VMware, we have a sort of enterprise-centric viewpoint on things. And so we're trying to sort of address the FAS use cases for enterprise, where we don't think that the existing open source alternatives for FAS are necessarily addressing enterprise use cases, which include multi-tenancy and integration with your enterprise directories, like Active Directory or whatnot. Also, they don't necessarily have a secure ingress. Like if you're familiar with AWS Lambda, they've got this event gateway service, which is a way of routing HTTP requests to trigger functions. And this is also something that Kong does very well. And so we chose Kong we chose to use Kong within Dispatch to gain this functionality. Also of note, within AWS, I think I've read that 80% of their functions, of their Lambda functions, are actually triggered by API, requests coming through the API gateway. So this is I think whether or not we remain with Kong, an API gateway is a key component to FAS, and that's why we chose to include it. Mark already talked about cloud events, so we have and the properties of functions in that they are event driven. This is sort of one of the first things that we came up with when we were thinking about where we were going to build with Dispatch, is that especially in an on-premise environment where we don't have the luxury of a whole bunch of services that are integrated together like they do in the public cloud, where it's very easy to trigger like a Lambda off of a notification from an S3 bucket, where someone posted something to a bucket, and now I want to do something like an image resize and have that triggered automatically through the AWS internal bus. We want to, essentially enable that same functionality, but on-prem, which means that we need to be able to import events from external services, such as an S3 or public cloud events. But we also want to go beyond that and be able to integrate with internal events. And so, stuff like vCenter events. So for instance, being able to trigger functions when a VM is deployed. So, and you'll actually see a demo of that at VMworld if you're around. Anyway, so we have an event bus that is Kafka based and speaks cloud events because Mark's been part of that space. And if cloud events becomes the spec that we hope it becomes, or the standard that we hope it becomes, it'll be very easy to transit events around and integrate dispatch with any event source. And then also, which you'll see in a demo later today, we integrated with the Open Service Broker. And so Open Service Broker is really, it's kind of an API for managing external services such as databases, queues, and whatnot. And it's really just an API for managing their life cycle. So you can bring these services up, you can bind them, which really just means getting credentials for them, and do this programmatically. So you can use external services from dispatch or anything that's integrated with it. And then of course, one other important piece is you'll see that we've drawn a circle around FAS in case we have this open FAS icon. Dispatch itself is not a FAS. So dispatch itself does not do the function execution. We leverage other existing FAS services for that, such as OpenFAS, such as RIF, which is a pivotal project. And we chose to do this initially because there, even at the onset of dispatch, there were already a lot of FASs out there, and they're responsible for scheduling and executing functions. And we didn't think we could provide a lot of value in doing that ourselves because, that's something that someone else is doing quite well. We can just leverage that, and that's kind of what we've been the story around dispatch as a whole, in that we are more like glue around all of these existing open source projects, and we provide a uniform API and IAM policies around that API. So what does our architecture look like? As you can see, this is kind of a simplified view. The control plane here is actually a series of microservices that are responsible for each sort of component that we talked about previously. Underneath it all, we're running everything on Kubernetes. That was a decision made early on that we chose Kubernetes to be our infrastructure. We consider that our IaaS. That allows us to run dispatch on a laptop using Minikube. It allows us to run it on VKE, PKS, EKS. Basically, any Kubernetes service we should be able to run on because, and that allows us a lot of portability and makes life easy for developers and administrators. Don't know what else to mention here. You can see that we're all the gray boxes are kind of our dependencies that we're managing. So with that, I'm going to go straight into a demo. The demo I'm going to give, this is a demo I gave a while back. I think you saw Mark's use case slide a little bit earlier. This is the REST backend use case. So we're going to build a web app, and it's going to be backed by dispatch functions. Additionally, we're going to use the service broker to manage a database that provides the state. So functions themselves have no state. They rely on external services. And we are going to show that we're going to use an external database hosted in Azure to provide the state for our little notes application. So with that, I'm going to switch to demo mode. All right, so let's see, let me get this little thing out of the way. I'm going to start with sort of the more or less end state. This is the UI for our notes application. As you can see, it's relatively blank. If we refresh, still nothing comes up. And if we inspect, we can see that, let's see, it's all pretty small, but what I really want to show is that we've got a bunch of 400 errors or 404s for a backend that doesn't exist. And so what we're going to do in this demo is create that backend. So to create that backend, we're going to use dispatch. If you want to follow along now or later, this whole demo is actually checked into GitHub under the dispatch framework organization. It is the Notes app. And so I'm basically going to be following these steps. I've already deployed the UI. I've also already deployed the Postgres server. And the reason I did that is it takes a long time to spin up, but I'll show you how you do that. So let's maybe even start with that. So as I said, we need a Postgres. Postgres database, and we're going to use the service catalog or open service broker functionality to do that. And we manage that with dispatch. So we can see that dispatch get service classes. So I've associated the Azure service broker with dispatch. And so this gives me access to all of the Azure services that they make available with this service broker. You can see the list here. And then I have already dispatch get, so can't see anything. Okay, get service instances. You can see that I've already deployed one. It takes about 10 minutes to deploy. I did it with this YAML file. So this is how we describe a service through dispatch. You can see that a lot of the parameters are actually defined by the open service broker and its schema. That's where the firewall rules, location, all come from. These are all Azure properties. And then you give it a name. In this case, was Postgres, and that's what shows up when we look at instances. And so, provision means that it has been deployed in Azure. Bound means that we have also gotten a secret. We have gotten credentials for a database. And then those credentials are then stored in dispatch secrets, and which can be seen, get secrets. And so it just has a UUID name, but this is the Postgres. The credentials to this Postgres database are stored within this dispatch secret. Okay, so we've got our database. The next thing to do is to create an image. So images within dispatch. So let's look at what we have. Dispatch get base images. So I'll start with base images. Base images are, as the name implies, they're really just sort of what's called the operating system plus the runtime. So in this case, we have base images for Node.js, PowerShell, Python, and Java. This particular demo is a Python demo. So we have this notion of base images and then images. Images capture the runtime, but then also dependencies that you might need for your function. And so our function is going to talk to Postgres and therefore has some dependencies on Postgres, like a Postgres client, as well as some a lightweight ORM that we're going to use in our function as well. So we need to capture those into an image. And so this being Python, we specify those with a request.txt. So request or requirements.txt. These are the specific dependencies that we need, and then that goes into the image definition. So vi images or image.yaml. So we're creating an image. It's based on the Python 3 base image. We're calling it Python 3 notes server. It has the dependencies listed in the requirements.txt. So we're going to go ahead and create that. All right, so that got things going. You can check the progress. me spell it correctly. You can see that it's in creating state right now. We'll wait for it to get ready. Might take a second. What it's actually doing here is it's creating a new Docker image that includes these dependencies and then storing it on an internal Docker repository. Still creating. All right, well, it's definitely taking longer than it should, but let's just go into what a function looks like. And hopefully by that time, the image will be ready. So okay, so for the functions, we're going to create two separate functions. Our notes application is going to be able to add notes, and then it's also going to be able to list out the notes. And we've specified two separate functions for that. The way we define functions is similar to images. I use a YAML file because I think it's easier. You can see that you specify the source path. The source path is actually, it's a path to a Python source. And you specify, in this case, you can pass in services. You can also pass in secrets. I pass in the service, which is made available to the function in the form of a context, and I'll explain that a little bit more. And that basically implicitly passes the secrets into the function, so that if we need to connect to the database, and we can do that binding without actually hard coding any credentials into the function itself. And so add note, get note look very similar from this perspective. They actually look relatively similar in code as well. All right, good, our image is ready. I'm a bit relieved. So let's look at what the functions look like. Get notes. So get notes is sort of our list, right? It's going to connect to the database and get back all of our notes. A lot of this is just kind of specific to, well, most of this is specific to the function, which is good. Like Mark was saying, you really kind of focus just on the business logic itself. I think the most sort of the piece to really point out is this handle function. So the handle is sort of the entry point into the function, and all functions, especially Python functions, they're going to have a function signature that looks pretty much identical to this. But all of the different languages will have something very similar, in that it's a function and it takes two arguments. The two arguments are a context and a payload. So the context is going to include anything sort of specific to the framework, and this is where we're going to inject secrets, we inject service bindings. We also, in fact, add, if you're coming in through, for instance, the API gateway, we pass in any HTTP context. So it'll tell you, like, hey, what path did this come in on? What was the request, or what was the HTTP method, and whatnot. It's just sort of where we can inject information through the framework and then make it available to the function. Payload, on the other hand, is sort of the explicit input to the function. And so, for instance, when we're creating a note, the payload is going to include the content of that note, and it's what is actually sent. It's the arguments to the function when you're triggering it. So you can see in this particular function, it really doesn't take any arguments. We just are going to query for all the notes and return them. The functions take in, so both the context and payload are maps, and we also return a map, or really any JSON compatible structure. The add note is, like I said, is very similar, except in this case we are taking the contents of the payload. In this case, you can see the argument is going to be text within the payload, and creating the note, and then this note.create is going to save that into the database. Oh, I guess maybe worth stating. You can see these service bindings here. So that is our connection. Those are our credentials to the Postgres database that we've linked. Okay, so let's go ahead and create the function within dispatch. Okay, and similarly, we're going to have to wait for the functions to be ready. I'm using a relatively slow Kubernetes cluster. This is all actually running on VKE, so I shouldn't, but it's a development cluster, not a production cluster, and as such, the instances are a little bit suboptimal for performance. But anyways, that went a lot quicker. You can see they're both ready. They both have a Docker image URL, which is essentially what we're doing when we're creating a function. And the last thing we need to do is now expose these functions to externally expose them. We're going to do that through the API gateway. So we're going to create two API endpoints, one for listing, one for adding new functions. And you can see how those are defined also. So we've got two defined here. One is going to be a get method. The URI is going to be /notes. Cores allows it to work across domains, which is important for us in this demo. And we're pointing it to the getNotes function. Similarly, we've got a API that we're calling postNotes that's linked to the addNote function. It takes a post method and same URI. Let's create that. All right. And those are both ready. So we've created everything to create for a backend to this Notes application. So what happens now if we refresh? Look at that. We've got a note that was created earlier. So we know that it's actually connected to a backend. Similarly, I can say, hello, webinar live this time. And if we create, all right, so it kind of disappears. And if we look down here, we can see our node is here. To prove that it's real, I can refresh, and it's still there. So again, this is just a sort of simple application. You could create, as complicated a web app as you want. Dispatch function without service make creating these sort of simple web apps, webhooks, anything that require sort of what would traditionally require you to stand up like an Nginx server and a whole web app. You can do without any of that infrastructure. You saw me create it. All you have to do is really supply the function code, and then the dispatch framework will provide everything you need in order to serve that function and make it available externally. So that concludes my demo. And I guess we'll kind of move on to what we've got in dispatch today. So I've kind of tried to highlight a fair amount of the features, but I'll go through more or less everything. As I already said, it runs on any Kubernetes. I've also mentioned that we're wrapping phases and we support multiple different phases. We support a broad range of languages. I've talked about the Kong API gateway. Another thing worth mentioning is, we support Let's Encrypt, so that makes a deployment, especially a public deployment, very easy, so that you can all of the API endpoints that I exposed were HTTPS endpoints, and they're real certificates, which is very nice. In a production deployment, You can hook this up to an open tracing backend, so you can actually trace functions throughout the system, which is very important for debugging. I've mentioned that we have multiple IDPs. I didn't really demonstrate that. The cluster that I'm using right now is hooked up to GitHub, so I use my GitHub credentials to log in. We also support multiple organizations, and organizations is a you know, kind of a hard tenancy, so that you know, I'm just looking at the poll. Sort of a hard tenancy construct, so that you know, the use case being, if you deploy dispatch in a large organization like VMware, you could actually specify, hey, I want the CNABU to have this organization, and I want CNBU in this organization, and they can essentially use dispatch without interfering with each other. We have RBAC policies, so you can have different roles for your administrator of dispatch as opposed to your developer. Let's say you want to give your administrators the ability to manage the images and base images, where you want the developers to just be able to submit and execute functions. You can do that within dispatch. I've already mentioned that it's cloud events native, and we have this event driver, this extensible event driver infrastructure, which I haven't demonstrated. But that's kind of alludes to the demo that Mark was talking about from KubeCon, where we can pull in events from a broad range of sources, and we provide the drivers for that. They're also very easy to write your own driver. And then I demonstrated part of the open service broker integration. This is an open source project. We take any contributions that we can, and we'd love you to become part of our community and help out. We're always looking for people within VMware and outside of VMware. If they've got use cases for serverless or functions or dispatch specifically, we'd love to hear more. And I guess that's it for contributing. Here's a list of links associated with the content that we just showed. Most important probably being dispatchframework.io. And I guess that concludes things. So we've got some time for Q&A.
Excellent. Thank you so much, Bernd and Mark. So we got one question here from Reju. How long would the Docker container remain alive? Let's say the notes application, and what would happen to the images?
So the images themselves will remain as indefinitely, or as long as that function itself is defined. So if I go through and explicitly delete a function through dispatch, that will delete the image. It will also deprovision that container which the FAS is managing. With regards to how long that container is scheduled by the FAS is more or less FAS specific. So some FASs like OpenFAS will always have at least one container running for that function definition, whereas something like RIF, which scales all the way to 0, will have some sort of timeout where if the function is not invoked after a certain period of time, it will scale to 0. As soon as it is invoked again, there will be a little bit of a warm-up time to reprovision that container and serve the function.
And I think what you're talking about there is really important to iterate on the warm-up time that's needed if a container is not running and you're trying to hit that function. Of course, there will be a little waiting time before that function is ready, but usually not that long, right?
Yeah, like I said, it is kind of FAS specific. With OpenFAS, you will hardly notice any because that function will already be provisioned. Whereas like RIV, the process for provisioning that function is actually a Kubernetes deployment more or less, and so it takes a little bit of time, and it is language dependent because a Java function, for instance, is going to take longer to initialize than say a Python function. But yeah, I mean, this is kind of something that should be considered when you're deciding which backend to choose.
But this is also one of the areas where functions make it easy that you don't even have to think about how that Docker container gets scheduled, it gets deprovisioned, et cetera. That, with Docker, I need to actively say, run this container. With functions, I just wait for the events to come in, and the functions as a service takes care of the container orchestration and provisioning of that.
It's true. You don't have to write a Kubernetes deployment in order to schedule that function or schedule that container. I've been using Kubernetes for quite some time. I couldn't tell you all of the fields by heart that are required in a Kubernetes deployment. I'm still copying and pasting examples. And so this is why a project like Dispatch exists, and why serverless exists, is to make that easier for developers.
So I want to talk a little about the result from the poll here. Thank you so much, everyone, for the participation in the poll. So the second question, we'll start with the second question here. How soon will you be deploying on-premises serverless functions? We had a few that talked about deploying them within 3 months. We had a few as well that talked about within half a year, and then the large majority said don't know. Would you say that this is something common that you see? Is it because the technology is still fairly new?
Yeah, no, I'm not surprised at all. The technology is new. The vast majority of folks using serverless are using AWS Lambda, and there have been other services with other cloud providers that they haven't seen that much uptick yet, as well as a lot of on-prem solutions that also haven't seen a ton of real sort of usage. I think it is very new technology. It requires it's a different design pattern. It requires a little bit different thinking. And so it's going to be a while. And, this also, this impacted how we designed Dispatch also, in that, we didn't choose our own FAS. We didn't choose a specific FAS. We didn't write our own FAS. We tried to keep the whole thing very flexible, because we know that the landscape is changing rapidly. And in fact, if you paid attention to the Google announcements, they just announced a serverless, some serverless building blocks in Knative, which is going to change the landscape again. So I think it'll be a while before this sort of settles out, and so I'm not surprised.
But we have been talking to a lot of customers, and they definitely see the value in serverless, that they understand why they want this and have some initial use cases for being able to put this in place in their infrastructure. But to Barent's point, it is early days with respect to on-prem functions as a service. And what we wanted to do with Dispatch was provide something that was slightly opinionated in terms of helping to ease the installation and providing the tools necessary, such as API gateway, cloud events, et cetera, that would make it easier for customers to be able to engage with something that is enterprise class for trying this out.
Cool. We got one more question here from Reju. Does the backend, so the backend that you showed in the demo here, Postgres and Azure, does that typically need to be pre-provisioned, or could that also be provisioned dynamically from the function?
I could have demoed it. It is, we manage that all through Dispatch. So I think I showed the YAML file for it. If I had just changed the name and hit Dispatch create, it would have provisioned and created both a new database and a binding for that. It is all dynamic. It is not provisioned at the time of function run. Like, it is something that you do provision before you're going to execute that function, particularly because it takes time to bring up, and it also represents your state. And so it's not something that like a function scales to 0 and it's on demand, right? But Yeah, no, it's all managed within dispatch.
But also, if you have events coming in, you wouldn't want the function invocation to be creating the database.
Right.
Right. And typically what we see is that you will bring up the supporting services alongside when you're creating your, the functions, et cetera, in order to now deploy your entire web application or function plus services.
Mm-hmm.
So that's typically not done as part of the function itself, but as just part of bringing up the application.
Yep, that sounds good. Got one more question here from Tom. Which open service broker are you using? In the demo, you showed the Azure open service broker. Are there others available?
Yeah, so we leverage a project called it's actually a Kubernetes project. I think it's in incubator still, but it's the service catalog, which is sort of it's an interface from Kubernetes to open service brokers. And open service brokers all implement the open service broker API. And so there's really no limit to which open service brokers we can interface with. For my demos, I have open service brokers for Azure as well as AWS, but that's just because of the demo that I'm giving functionality. But as long as they're open service broker API compatible, you should be able to use any.
Awesome. No more questions there. So let's go back to the poll. The first question we had in the poll was, have you ever used or deployed a serverless function? And we got about a 50-50% response in yes and no, and we had one person respond don't know. And that's perfectly fine because you might have used one without knowing it. So yeah, that question maybe should have been phrased a little differently. So I've recently held 2 workshops, one workshop and one hackathon regarding functions as a service, and it's a huge impact when well, not impact, but huge interest rather in learning about serverless and functions as a service. Where would you recommend someone starting out to go and learn more about this?
I mean, honestly, if you just want to be, so there's a couple places. If you just want to play around with it, if you want to use a hosted service, the public clouds have FAS that you can play around with. If you're specifically interested in something that you have a little bit more control over, want to run something on-prem or on your laptop, I would suggest OpenFAS. Not just because Alex Ellis is part of VMware now, but also because its intent is to be simple and to help people learn about serverless and FAS. And it's got a community, and it's a great place to start.
Yeah, I agree there on OpenFAS. That's what we've used both for the workshop and the hackathon. Mm-hmm. And the OpenFAS also has a workshop. It's all on GitHub that you can follow along. It takes a few hours, and it's all self-paced. It's very simple, and you walk away with having a full-on OpenFAS implementation on your laptop. So it's pretty neat.
And I'd say the distinction between OpenFAS and Dispatch is that OpenFAS is a wonderful project for being able to run these functions on your laptop, or even you could even use it in production. But what Dispatch is attempting to do is pull together some other building blocks and also looking at the enterprise use cases that OpenFAS is not addressing.
Well, we're trying to build a multi-user service,
right.
Which is, it's just, they're similar projects, but sort of attacking different use cases.
And as Bernd mentioned, we can actually use OpenFAS as the underlying functions as a service in conjunction with what Dispatch is providing.
In fact, the demo today was the function executions were being handled by OpenFAS.
Cool. Got one question here from Motonori. Regarding API gateway versus event-driven, you said that the majority are coming through the API gateway, at least in the Lambda case. Why is that? I thought FAS would often be event-driven.
I mean, you can make an argument that an HTTP request coming through an API gateway is an event. So I don't think there's necessarily a distinction between the two. The only maybe distinction that I would create, that I would make, is that HTTP requests in general are synchronous. And so whatever interface you've got with the API gateway needs to both trigger the function and then also wait on the response and then serve that back. But I think the reason that most events are triggered through the API gateway is because a lot of people are using FAS, using Lambda for the use case of building web apps and webhooks.
Creating APIs.
Creating APIs, like that is I've been building web apps for a long time. Like that is my primary use case. And for creating something very simple like the Notes app or like a Slack integration or whatnot, it's a lot easier to just write a small function, expose or link a single API up to that function, and then use that as your external publicly accessible endpoint. I think that it's a solid use case, and I think that's reflected.
And there are other use cases or other events that come in from AWS, from S3 or SQS, et cetera. It's just that we think that the majority of them are coming through an API gateway, primarily because of that webhook and API, creating new APIs.
Dispatches.
Great. Yeah, we got one last question here before we're gonna wrap it up. So this is from Ray. Would you say that Dispatch is the abstraction of open source projects in some way regarding OpenFast, Kong, or would you say it's a VMware version of those projects?
It's definitely not a VMware version of these projects. Dispatch tries to be something different. I mean, we are leveraging one of the ways I describe Dispatch is that it is the stack of technologies that you would have to supply or build if you were going to put FAS in your enterprise environment. And we've tried to wrap those all up together as a single package in Dispatch. But we are not trying to, it is not a version of Kong, right? We are just leveraging Kong for its functionality.
Yeah, we don't have additional changes made to these open source projects. We're trying to leverage the open source community, be able to embrace and extend with respect to how Dispatch uses those and deliver an overall better experience for enterprise on-prem functions as a service.
Great. Okay, now comes the real last question here. What about metering? One of the important concepts around functions as a service is pay per function call. How do we see that in case of Dispatch?
I mean, similarly, the concept of metering and quotas and all that has come up, and it's something that I would say would be in our roadmap. It's not something that we have necessarily addressed, but particularly with tenancy, you want to ensure that tenants are provided a certain amount of resources so that one tenant doesn't hog all of the resources. This is particularly important on premise where it's not necessarily hyperscale, and you do need to have some sort of management around that. With regards to like chargeback and whatnot, I mean, there are use cases for that as well. But short answer is it is important. It's also on the roadmap.
So metering could be, when I hear that term, it could be, how do I limit the total amount of CPU or memory that's being used by certain functions? But also, we've heard from customers that they want to be able to get the total amount of CPU used, the resources that were used, provide billing and chargeback based off of that. And so I see that those are two very interesting areas for dispatch to be delivering on. I believe that we have some open issues on some of these.
Yeah.
Excellent. Thank you so much. So Bernd, Mark, I want to thank you both. Where can we find you on Twitter if we wanted to reach out to you?
The Twitter handle is dispatchfw. That's one of the ways to reach us. If you have specific questions about wanting help for deployment or just want immediate feedback, we're also available on Slack. On the Jonas, you would know the specific URL. It's the code Slack.
Yeah, if you flip back one slide, I think you have it there.
That's true. It's on. Yeah, that's right. As the dispatch channel on there.
There we go.
Yeah.
Awesome. Well, thank you both so much. This has been really, really interesting. Thank you all the attendees for all the questions and everything that you posted today. Really, really appreciate it. We wanted this to be interactive, and it definitely was. So again, thank you. We'll post this up on YouTube as soon as we're done here.
Awesome.
Have a great day, everyone.
Thanks, everyone.